Good morning, mathematicians. I found out that the Honest Taurus is streaming at the same time as me. Oh, it's right here. Yeah, Stream Wars have begun. And for many years it will wage on. The Honest Taurus is streaming at the same. Okay. I realized immediately after I finished streaming yesterday that I just made a mistake in how I drew my pictures. See, the problem was this. The problem was this is supposed to come out a little bit this way, right? And this is supposed to come out a little bit this way. So then down here, right, this, when I quotient, oh, sorry, and this should come out this way, right? These parts are getting glued to each other. Yeah, but I guess I should make sure just not this part. Wait a second, does this actually help me? Oh my god. But it's the intersection, so it should just be like a little blob around each point, right? No. Okay, I guess I have to compute the free product. Yeah, so here's a question. How does one model the free product of groupoids? I mean, for groups, or amalgamated product or whatever. For groups, I understand, but for groupoids? Yeah. I want to know how to give it a concrete model, though. Being push-outs, categorical. Well, let's spend some time checking archive. No one's said anything in chat yet. Has everyone abandoned me for the Honest Taurus? The Jacques Langland's correspondence for non-Eichler orders. Oh, look at this. I remember to change it to live chat right away. Spectral moduli problems for level structures. I have no idea about that. Interesting. Everyone unsubscribed because there's no merch. Yeah, fair. Wow, I'm trying, yeah, I don't know. I'm trying to write my thesis. I'll make merch soon. Like I said a while ago. Interesting, though, because I do know of a new paper, and I don't know why I don't see it here, that someone sent me. But maybe it wasn't given the Langlands tag, I don't know. You're fashionably broke, so won't be buying anyway unless it's hobo coded. No, I don't think it will be. It'll probably be more expensive than I want it to be. Yeah, this is the paper. But what's this classification? What was it under? Math? Oh, it was under representation theory. Blue collar but zero physical labor. I don't know, if you were blue collar, you probably wouldn't be broke. You can make decent money doing blue collar stuff. I should have just started my own, concrete pouring company or something. Yeah, so here's a paper about supercuspidal representations of SL2 over an extension of the two-adic numbers, which is really interesting. That Monica actually just shared with me. And by the way, this person, Xander, I think they're still in high school, which is wild. And they're proving stuff about co-authoring these papers about supercuspidal representations of SL2, which is very cool. Your first year math student, any advice? Not really. I don't know. It's hard to just give such general advice, have fun, I guess. Have fun. I don't know. Go make use of your professor's office hours, even if you don't need them. Just go and talk to people and ask questions and build those relationships. That's some advice I'd have for you. Geometric group theory is best funding. Okay, so I think that's you're being sarcastic based on your other sentence, based on your second sentence. I have no idea how much funding geometric group theory has, though, mind you, I guess I haven't seen much of it. So, if it's comparable to large cardinals in logic, then yeah, probably not much more. Sasho, more advice, actually. Definitely, it's never too early to start going to conferences and summer schools. Of course, earlier on, you'll probably go and you won't understand, a damn thing you're supposed to be learning about in the lectures. But yeah, I think it's still worth it. Like, go to seminars, join reading groups. It's just part of this whole, networking and knowing people. it's important, and getting exposed to many different ideas. So yeah, that's some more general advice, I would say. You're a chemical scum. Interesting. I suppose everyone here is chemicals. Maybe not chemical scum, but I mean, I'm drawing this diagram and thinking about these as spaces. I probably shouldn't be doing that. How often do I find out? How often do you find out you and some other group is doing similar research? All the time. Just with a different sounding language, not even different sounding language, or vocabulary. No, that's not a thing. That's not a thing because I did switch from top chat. Yes, thank you, Thomas Boyko. Thank you. Hello, Rod. But no, that's not a thing. Like, people use similar language. I mean, the idea with writing math papers is to be understood. So, yeah, it's not like, yeah, it's very unlikely you're going to accidentally stumble upon someone that's doing the same thing but calling it a different idea. No, because we're all building off of the same papers in the same community. So yeah, other groups work on the same things, but yeah, this wouldn't be something we discover by, oh, they're using a different language to describe it. Not to say that couldn't ever happen, right? Like, for instance, we're doing things for the purposes of Langland's program, and then, we're trying to work out some algebraic geometry problem, and maybe that problem already does have a name, and is proven in some old algebraic geometry paper that we don't know of. Oh, okay. Could happen, but yeah. Thanks. You have the opportunity to stay at your local university, which is top 100. Oh, or go to top 15 uni. Is it worth it for bachelor? I think so. I think so, personally. Yeah, I mean, okay, probably the teaching is maybe not going to be that much different. It's not like you're going to have such a better educational experience. But if you're close to high profile people, then I think it's just more likely that you will get a chance to do research with these high profile people, or get letters of recommendation from these high profile people, which will then allow you to go on, give you better chances of going on to, do a Ph.D. at a high profile university. And then again, that will increase your odds of getting involved in some high profile research. So, yeah, I mean, absolutely, if you have the chance to go for a top 15. Well, so I should say, just the way you worded it, I'm not sure. So the top 100 is top 100 globally, and top 15 is top 15 globally, or you say top 15 in Europe, as in top 100 globally compared to top 15 in Europe? I'm probably still the top 15 in Europe is close to top 15 globally. So probably that's still a good move. Now it depends a little. I mean, how closely are these universities actually ranked? If they start to become pretty close in ranking, then I don't know. Maybe consider it. Um, you do also want to consider if there's people there doing things that you're interested in, both in Europe. I see. Okay, yeah. So I would say go for top 15, and yeah. Yeah. Also, I just think as for your like well-being as a human being, I mean, I don't know, maybe arguably some people their first time away from home or something can be very stressful, or you're very connected to your family or something, but ultimately, I think if you have the opportunity to go somewhere new that you haven't been before, this is probably just like better for your development as a human being to like see more of the world and spend a significant time in the world. It's a interesting experience, and you should probably fill your life with interesting experiences. So, yeah. You thought occasionally some group uses an approach they believe is novel, but it turns out to be some slight variation or ideas from an existing theory in a novel way. I don't know how common that is. I mean, there's like this famous story of these like in the 90s or some, I don't know, biologist or something that ended up like reinventing the trapezoid rule from calculus. So like stuff like that happens, definitely, but I wouldn't say it's extremely common. Hello, Sergio Polar Bear. I hope you're less violent than a real polar bear. Can I help you with some exact sequences of normal bundle and CPN? More details if interested. Okay, maybe, but I'm still not even done the fundamental groupoid thing. Yeah. So yeah, I'm not even sure. I mean, you can put the details down, Paul Maurice, but I haven't even gotten to your question about atal cohomology, amalgamations of categories. Maybe that's what we want. Right, because I guess this push out is like a push out of categories, right? It should just be a push out of categories. Is that true? No, this is gonna just give me the ordinary push out. When applying for PhD programs, would I also recommend prioritizing your choices for universities that are likely and have good research groups rather than aiming at the highest ranked areas? Well, I mean, these things are very closely correlated. Of course, there can be great research groups at smaller universities, but go look at the list of Fields medalists and go look at where they did their degrees. You'll see certain universities come up a lot. Yeah. So I don't know. These things are not separate. I mean, one thing that is maybe somewhat separate is you should consider if the university has people working in areas that you think you're interested in, but you should also think about what are areas you can get a job in. So, if you're interested in some obscure thing, speaking of the field with one element, that New Wave Infantry asked about the other day, when I was applying to grad school, I reached out to a guy and I said, hey, can I, I'm interested. He did research with the field with one element. I was like, oh, I'm interested in this area. And he's like, okay, I could take you as a student, but just be advised, like, there's not a lot of people working in this area, so it's maybe not the best idea for an early career mathematician to try and get a job. It's just winding number of S1. Okay, why is it just the winding number of S1? Ties model. Oh, medicine calculus paper. Oh, nice. 600 citations. Wow. So all I need to do is just reinvent calculus and pass it off as my own. Okay. Enumeration of rational curves via torus action. So if you can settle for a research group that's in a top 30 to 50 school that still does research you like, rather than investing attention strictly at the very highest institutions, yeah, I mean, it's a tough call. Probably yes, that's better. I mean, you shouldn't do research that you're not actually interested in just because it's prestigious. You're probably not going to get very far trying to do things that way. But I don't know. This is I don't think something one can give a general answer for. Yeah, this sequence here. Contribution of H0, space of global sections of this vector bundle is equal to this space. Edge of gamma is a graph given by the condition that values of sections at each vertex. We have a following short exact sequence. Looks like the usual normal bundle sequence for smooth subvarieties. H0. You can derive it by taking the short exact sequence of the subvarieties, defining ideal sheaf, and tensor it with the twisting sheaf. That's not what you're after. In the middle of the page, Paul Maurice, why do you think I'm going to be helpful with this at all? Why? Middle of the page is the exact sequence. Is this the exact sequence? Given to find the basis of tangent bundle with various index. Yeah, so what am I looking at here? This is the tangent bundle of Pn, right? And this is what the normal bundle, Lij, this is the tangent bundle of some subvariety. And N is the normal bundle. The 1 and 2 are written for basis. I don't know what you mean. I don't see any 1s or 2. Oh, here. This is what you mean. The 1 and 2 here. The edge alpha. I still know what this how this is supposed to be an edge. Some graph embedding? Okay, whatever. And some coordinates on P1. On Lij, yeah, but what's Lij? I mean, I feel like there's definitions I'm missing here. I gotta go to the start of the paper to read this. Compact reduced curve. Yeah, moduli stack, blah blah blah. Come on, Paul Maurice. What were you thinking? No, H0. I don't know what you mean by that. What are you trying to tell me by just writing that? Is Langland's program really more approachable for early career researchers? Well, I mean, it's not so much about approachability as it is like a viable option. Like Langland's is obviously quite popular, so you're more likely to get a job working in Langland's. Boy, some of the formatting on this paper is intense. I don't know what you mean by that. Seems normal to me. Appreciate the input. If you have currently have given you advice to not invest overly much attention strictly top universities, and if you do wish to apply, only apply to 3 to 5 of them. Well, I don't know. That depends on. I mean, you should try to get into a top university, but you also should be very honest with yourself and realistic. You know, do you have research results as an undergrad, and do you have like a 4.0 GPA? Then, definitely put a lot more eggs into the basket of applying to Harvard and Stanford and blah 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 in these places. But if you've got like a 3.5 GPA and like limited to no research experience, then yeah, I probably wouldn't apply to too many of those schools. You should definitely apply to some reach schools that are like, maybe a reach for you to get into. But yeah, I think, you need to have a honest discussion with yourself, or, talk to a professor and, just, I don't know, be prepared for the honest truth. Ask them, what do you think I should be aiming for? Ask some professor who actually knows, has some sense of your abilities. Because you don't want to go somewhere, you don't want to put all your eggs into the basket of applying somewhere that's beyond what you can get into. You also don't want to set the bar too low for yourself. So you want to, I don't know, have an accurate aim. Of course, aim a little bit higher than what maybe the expectation is. Shoot for the moon and all that. But also, it's worth getting an accurate assessment. After one can check, indexed point 1 and 2 explanation. After one can check. After... the one can check. Sorry. One can check using this exact sequence that the following elements form a basis of this. Okay. Well, I mean, these parts are coming from the tangent bundle. And then, I mean, what is the map F? Because you can, F should be exact, right? So if you pull this back, you'll then get an exact sequence with F star here. And then what is H naught C? Okay, yeah, so then you're on C. And then I guess you take cohomology and get a short exact sequence. Right, because this is what the map is given by. I mean, H naught is, yeah. Right, so we should have this, and then we should get I gotta make this sequence too short. No, we can't. This is sacrilegious. I need to have all three terms on one line. And then we should have H naught, F pullback, N, Lij, H1, T, Lij, dot, dot, dot. Okay. And so we're interested in the middle term. So we have a basis. We have a basis of something like xij's. I mean, locally, if we look at some affine patch. And then the map is given by yeah, I don't really get how the map is defined. Pink? Maybe the color settings on your computer are weird, because that's red. I used purple and I used red. This is definitely not pink. But I'll use a different color. The map F is given by, I see, so xi of fz is z1d, and xj, huh? What? So we've fixed an I and a J. I guess. We've fixed an I and a j. I see. We fixed an I and a j as z1 to the d xj's z2d, and then xk is 0. For k not equal to ij, is this real deal math? I guess so. Right. Mm-hmm. Okay, so... Right, so this is a map to P1. Wait, F is given by... Right, or sorry, a map. Right, so F is from a copy of P1 to Pn. And then we're pulling back, right? So if we take like the pullback, this is the monster math you've been hearing about. Well, no, that's group theory, Brian. That is group theory. That's monster math. That's real monster math. So the pullback of this differential, the pullback of this differential, how will a basis of that with d dx arise? I mean, just squinting at it, it kind of makes, I mean, we need to do the formal computation, but just squinting at it, it makes sense to me. Like, right? I mean, it's a little weird. I don't know what these D's are. Yeah, I don't know what D is supposed to be. I guess that's also some fixed constant from somewhere else. But I mean, just looking at how this map is defined, it kind of makes sense how this is gonna show up, right? I mean, these parts are the basis terms. These parts are the basis terms for the tangent bundle. So then, okay, you pull back. The first one can be made sense, but no clue about the second one. Yeah. D is degree of map. Okay. Yeah, I mean the thing is we have I mean I'm guessing some part of it should come from the exactness or I mean this isn't yeah, I mean this is exact. So I guess if we knew something about the relationship between these things, right? Like we know that we have a short exact sequence from the image, like we have a short exact sequence from here, so I guess it'll be like, I don't know, the image of this map, right? To the image of to the, I mean, you could call it from the kernel of the next map. I guess this is the, cohomology, the snake map. So, but yeah, right. Like if you think about what's happening here, I mean, you should somehow be like killing off the terms that belong to Lij, right? Yeah, I mean, Paul Maurice, you're always just coming in here asking me crazy ass questions from all over the place. It does, not complaining, but it is like some, crazy ass qualifying exam. Have I tried 4 cups of coffee for inspiration? Or Paul? Maybe we should all have 4 cups of coffee. You need to understand these for some Gromov-Witten invariants. Okay, well, I do need to go. We may come back to this. But that is where I'm going to leave office hours for today. Yeah. But I think it should not be so bad if you just compute those and then use the fact that you have the short exact sequence. Seems reasonable. Great to catch one of these live. It's fun to get a glimpse. Oh, by the way, I mean, this should be a vector space, right? So probably you could take it as you can just treat this as a vector space. So you can just take the sum of these two things, maybe. I don't know. To the algebraic side of math as a student in analysis. Nice. Well, I'm glad that you found this useful. Maybe we'll talk about some analysis tomorrow. Who knows? Okay. That does it for today.